Welcome, my friends. Consider the expression negative x to the third power plus 5x squared minus 6x plus 8 divided by x minus 4. There are two ways this can be divided out, either with synthetic division or long division. I will show you both ways. First, let's use synthetic division. Synthetic division only works if the denominator, often called the divisor, is in this form, x plus a constant or x minus a constant. We have x minus the constant of 4, so synthetic division will work. Take the opposite sign of the constant and write it off to the left. We have positive 4. You can also think of this as the value for x that will make the denominator equal to 0. Then you make sort of a chart like this, and write only the coefficients of the numerator, called the dividend, in order. So we have negative 1 for the coefficient on x to the third power, 5 for the coefficient of x squared, negative 6 for the coefficient on x, and 8 for the constant. You have to make sure to write the coefficients in order from largest to smallest degree. Next, you bring down the first number, which is negative 1. Now multiply negative 1 by 4 to get negative 4, which you write here. Now add. We have 5 plus negative 4, which is positive 1. Then we multiply positive 1 by 4, which is just 4. Negative 6 plus 4 is negative 2. Then we take negative 2 and multiply by 4 to get negative 8. Finally, we add 8 and negative 8 together to get 0, which is the ideal case. The 0 tells us that we have a remainder of 0, which I like to box off. Now, you should have some numbers on the bottom. They will be the coefficients of the divided polynomial, which will have 1 degree less than the polynomial that you started with. So since we started with a degree 3 polynomial, the new polynomial will be degree 2. So the negative 1 is the coefficient on x squared, the 1 is the coefficient on x to the first power, and the negative 2 is the constant. Altogether, we have negative x to the third power plus 5x squared minus 6x plus 8 divided by x minus 4 is equal to negative x squared plus x minus 2. Now, you can take this one step further and know that since the division is equal to negative x squared plus x minus 2, we can factor that out of the numerator. So the numerator could be written as x minus 4 times negative x squared plus x minus 2. If you are having trouble thinking about why this is the case, look at this equation. If you multiply both sides by x minus 4, you will get what I have written, x minus 4, negative x squared plus x minus 2. This is one of the main reasons why we might want to use synthetic division, to factor polynomials of higher degrees. Okay, as I stated, we could also do the same problem with polynomial long division. Long division is a little bit more involved, but always works. Remember that synthetic division only works when your divisor is x plus a constant or x minus a constant. Long division will work with anything. For long division, you write out the divisor out front and then the dividend inside. Make sure you write everything in standard form so that the degree decreases by 1 on each term. There are a few ways to think about what to do next, but the way I think about it is to find negative x to the third power divided by x. Just ignore the constant of negative 4 for now. Negative x to the third power divided by x is equal to negative x squared, so we write that up top. You could also ask yourself, x times what equals negative x to the third? Either way, you will get negative x squared. Now multiply negative x squared by x and by negative 4. X times negative x squared is equal to negative x to the third power, and negative 4 times negative x squared is equal to 4x squared. Now subtract term by term. Negative x to the third power minus negative x to the third power is equal to 0. You should get 0 every time for the first one if you've done this correctly. 5x squared minus 4x squared is equal to x squared. Now bring down the next term of negative 6x. Let's continue the process. X squared divided by x is equal to x, so we write x up top. multiply x times x to get x squared, and multiply x times negative 4 to get negative 4x. Subtract term by term to get x squared minus x squared, which is 0, and then negative 6x minus negative 4x, which is equal to negative 2x. Bring down the positive 8 and go through the process one more time. Negative 2x divided by x is negative 2, so we have negative 2 on top. X times negative 2 is negative 2x, and negative 4 times negative 2 is positive 8. Subtracting term by term, we get 0 plus 0. There are no more terms to bring down, so we are finished, and we have a remainder of 0, just like we did with synthetic division. The answer is negative x to the third power plus 5x squared minus 6x plus 8 divided by x minus 4 is equal to whatever is on top, which is negative x squared plus x minus 2. Just like before, this means the numerator of negative x to the third power plus 5x squared minus 6x plus 8 factors to x minus 4 times negative x squared plus x minus 2. Let's try another one that's a bit different. We have 2x to the fourth minus 14x squared minus 15x plus 5 divided by x minus 3. Let's try synthetic division first. We write 3 off to the side, as that is what would make the denominator equal to 0, and then we write out the coefficients of each term. We have 2, and then we notice that we don't have a term with x to the third power, so we need to write a placeholder, which we just put 0 in for. Then we have negative 14 for the x squared term, negative 15 for the x to the first power term, and positive 5 for the constant. We pull down the 2 and then multiply by 3 to get positive 6. 0 plus 6 is positive 6. 6 times 3 is 18. Negative 14 plus 18 is positive 4. Positive 4 times 3 is positive 12. Negative 15 plus 12 is equal to negative 3. Negative 3 times positive 3 is negative 9. 5 plus negative 9 is negative 4. So this time we have a remainder of negative 4. Just like last time, we can write out a polynomial that will have a power 1 lower than what we started with. So these values are the coefficients on our polynomial, starting with to the third power and then decreasing by 1 power each. We have 2x to the third power plus 6x squared plus 4x minus 3. But we still need to deal with the remainder of negative 4. The remainder is associated with an additional term divided by the divisor of x minus 3. So we have minus 4 over x minus 3. Altogether, 2x to the fourth power minus 14x squared minus 15x plus 5 over x minus 3 is equal to 2x to the third power plus 6x squared plus 4x minus 3 minus 4 over x minus 3. We can't write the numerator in factored form like we did in the previous example, as x minus 3 does not evenly divide this polynomial. Let's try the same problem with long division. We have x minus 3 off to the left, with 2x to the fourth plus 0x to the third power, since we need a placeholder for the term to the third power we are missing, minus 14x squared minus 15x plus 5. Next, we take 2x to the fourth power and divide by x to get 2x to the third power. X times 2x to the third power is 2x to the fourth power, and negative 3 times 2x to the third power is negative 6x to the third power. Subtracting, we have 0 and 6x to the third power. We bring down the negative 14x squared and ask ourselves what 6x to the third power divided by x is equal to. We have 6x squared. Then we take x times 6x squared to get 6x to the third power, and negative 3 times 6x squared to get negative 18x squared. Subtracting, we get 0, and then negative 14x squared minus negative 18x squared, which is positive 4x squared. Now we can bring down the negative 15x. 4x squared divided by x is 4x. X times 4x is 4x squared. Negative 3 times 4x is negative 12x. Subtracting, we have 0 and negative 15x minus negative 12x, which is negative 3x. Then we can bring down the 5. Negative 3x divided by x is negative 3. X times negative 3 is negative 3x. Negative 3 times negative 3 is positive 9. Subtracting, we have 0 as negative 3x minus negative 3x is 0, and 5 minus 9, which is negative 4, which is our remainder. Our answer is what we have on top, 2x to the third power plus 6x squared plus 4x minus 3. But then we have the remainder of negative 4, which needs to be over the divisor of x minus 3. So altogether, we have 2x to the fourth power minus 14x squared minus 15x plus 5 divided by x minus 3 is equal to 2x to the third power plus 6x squared plus 4x minus 3 minus 4 over x minus 3, which is the same answer we got using synthetic division. Now, I mentioned earlier that you can only do synthetic division if your divisor is x plus a constant or x minus a constant. What if we have something like this? 3x to the fourth power minus x squared divided by x to the third power minus x squared plus 1. Then you will need to use long division, as the divisor of x to the third minus x squared plus 1 is not just x plus a constant or x minus a constant. We have x to the third power minus x squared plus 1 out front. We don't need a placeholder for the divisor, although it works if you write one out. And then underneath, we need 3x to the fourth power plus 0x to the third power minus x squared plus 0x plus 0, since we are missing the third power, first power, and the constant. 3x to the fourth power divided by x to the third power is 3x, which we write up top. Then we multiply. X to the third power times 3x is 3x to the fourth power. Negative x squared times 3x is negative 3x to the third power, and 1 times 3x is just 3x, which I will write underneath the 0x term. Subtracting, we have 3x to the fourth power minus 3x to the fourth power, which is 0. 0x to the third power minus negative 3x to the third power is positive 3x to the third power. There's nothing to subtract from negative x squared, so we just copy it down. And then we have 0x minus 3x, which is negative 3x. We can bring down the 0. Doing one more iteration, 3x to the third divided by x to the third is 3. Multiplying, we have x to the third times 3, which is 3x to the third. Negative x squared times 3 is negative 3x squared. 1 times 3 is 3. Subtracting, we have 3x to the third minus 3x to the third, which is 0. Then we have negative x squared minus negative 3x squared, which is positive 2x squared. Then we just have negative 3x, which can be brought down, and 0 minus 3, which is negative 3. We can't do another iteration, as what's left is a second degree polynomial, and our divisor is a cubic, so dividing would give us negative exponents. So this part here is our remainder, 2x squared minus 3x minus 3. Our final answer is what's on top, 3x plus 3, and then the remainder over the divisor, which is 2x squared minus 3x minus 3 divided by x to the third minus x squared plus 1. Alright, my friends, that wraps up our video on long division and synthetic division of polynomials.